Hey everybody, I'm going to try something new for this video. I'm going to talk about Lua modules written in C, and the new thing is that I am live streaming this video first, and then I'm going to upload it to YouTube. So it's designed for viewing on YouTube, but I hope that the video may be more interesting because there are potentially live viewers who may say some things about the video. They may ask questions that might add to the video. So I'm going to talk about Lua programming in C in two parts. The first part, which is this video, is all about how to compile Lua modules in C. And it's about the logistics of what are the compilation flags, what do the C functions look like, sort of the very low-level logistics. And this is always the first step. This is the absolute essentials that you need to know about before you can build a Lua module in C. And then the second video that I plan to make later will be about the actual C API, and that will talk about more about the specific functions, and there's many of them, that they're C functions and they interact with the Lua runtime engine. So they let you basically write an interface that a Lua programmer could use, but you're actually coding in C, so you can do anything you could in C. You could add a GUI, you could talk to the operating system at a low level, whatever you want to do. I'm using a Mac. Lua is very portable, so basically everything that I will cover in this video works on all major operating systems, Windows, Linux distributions. However, the one thing that is very particular to an operating system is the way you compile the dynamically linking code. So I will do it on a Mac, and I will give you a URL that covers many platforms, including Windows and Linux stuff. And I have done very similar stuff on Windows and Linux, so I know that it is very similar. It's just mainly which compiler you use and the flags. Okay, so, oh, and one more note. If you're watching this on YouTube, I would be very grateful for comments on the YouTube video if you want to know about, if you have any specific questions, or if you want to know more about a specific platform. You know, like, are you a Windows developer and I didn't answer your Windows questions, for example. I try to be very responsive to the YouTube comments. Okay, so let's get started on the details. Okay, I'm going to start by reminding you what it looks like to write a Lua module in Lua. Okay, so let's write a sample Lua module, and I'll call this file sayhi.lua. Generally, the beginning of a Lua module written in Lua starts with a declaration of a local table, and the last line, generally, you return that table. There are slightly different styles of defining modules, and historically there were some different ways of doing it. This is sort of the modern way to do it. And in between those two statements, you can put in as much arbitrary Lua code as you want, and it will run once the first time your module is loaded, and only once, even if it's loaded again with the requires function. It's good practice to not define any globals, because you really want the end user of your module to have full control over all the global variables defined. So that's why I'm saying local say hi. And you know, a user, for example, maybe there are two different modules that are both called JSON, and one of them is very fast at parsing, and the other one is very fast at stringifying. And you want to use both libraries, but they have the same name, right? Well, by not defining the global variable JSON, as an example, you can let the user define one as like jparse and the other one as jstringify, for example. So let the user decide the global names, and you're just doing local stuff here. Within the module, you can define, you know, functions, variables, whatever you want to define. In this case, this module, all it does is it says hi. And we'll make it a very excited function right here. So in order to actually use that module, I guess I'll do it from a test script. And what I'll do is I'll have a local, and just to show you that I can give it a different name, I'll name it S. And then I'll run s.go. S stands for say hi. So now when I run that test function, it loads my module and it calls the function and it says hi. So as a reminder for what this module looks like, it looks like the body of a function. If you're used to other languages, you may scratch your head and say, why does it end with a return statement? That's a little unusual. When Lua loads a module with a require function, it basically loads the entire text of that file as if it were the body of a function. And the return value of that function is what gets passed back by the require function. Okay, so that's what's happening under the covers. And that's why all the local variables in a Lua module are not visible outside of the module. So that's the basics of a Lua module. The reason I started with that, even though I'm talking about C, is conceptually a C module works in a very similar way. It has its own variable scope conceptually. It's different because it's C. And then you return a value, and that return value is expected to be a table with keys that are your function names and values that are the actual functions. And when you're using a C module, you basically don't know the difference, more or less, between a Lua function and a C function. You just call the function, and it feels to you as a Lua user, it feels the same as if it were C or Lua function. So what I'm going to do, in order to be very complete, is that I'm going to start by actually downloading the source. Let's see here. I need a browser window. So I'm going to download the source of Lua itself. And just to show you that it's actually very reasonable to download and build from source, I will do that. So going to lua.org. I'm going to click on download. My font is enlarged so that it's easier to read on the video. And over here it has this these few shell commands. This is for building. It will download, it will unzip, and this will cd into the directory that it unzips. So I just copy and pasted that from the lua.org site. Now, by default on lua.org, it says make Linux test, which is for a Linux distribution. So in order to actually build, I will make Mac OS X test. And I know I use an environment variable called cd path, and I have to unset that. Otherwise, I know from experience that that environment variable messes up the Lua build process. By default, your cd path environment variable will not be set, so that it should not be a problem. Let's see here. Okay. So now I've built from source pretty fast, right? And I can run this, and Lua 5.3.1 is running. I can print out a test string. Okay, great. Control D to exit. So that's the interpreter that we just built. Now, in order to compile a C module, I need a few of these source files. And the main source file is called, very nicely, lua.h, but there's actually going to be a few that we need. We need the Lua configuration file, we need the auxiliary library, and that's it. Those three header files are usually all you need for 99% of your Lua C modules. I mean, you may need other header files for other functionality, but as far as Lua is concerned, those cover most of what you'll need. All right. I am going to write a C module called time. And just to tell you why I'm writing it, Lua by default, I'm going to copy the interpreter here, so I can use the 5.3 interpreter. Let's see, here's the version, yeah. So Lua by default can tell you the time, but it's only in seconds. So I'm going to write a module that will eventually allow me to tell the time with higher resolution timestamps. Okay, so this is a Lua module written in C to provide the time in sub-second resolution. Whenever you write a Lua module, you want to include lua.h, and there's one key function which is going to be named Lua open underscore, and actually let me get my slides up to date here because there's a slide here that mentions this. Lua open underscore and then the name of your module, and then it's going to take a Lua underscore state star capital L. Doesn't have to be named capital L, but that's what's expected. Now, normally what you'll do is you'll initialize the module, and then you'll return 1, which is the number of Lua-facing return values on the Lua stack. Okay, in L. Now I'm going to do something a little bit unusual here. Just to get started showing you how it works, I'm going to print hi from, and then I'll use this compiler-defined macro called double_function, and I'll return 0. So just to be clear, this is an unusual thing to do, and I'm doing it just to show you how this stuff works. So at this point, I have a C source file, and I can compile it. I'll show you the compile flags in the slide here. cc bundle, that tells it, the compiler, to make a mock OS bundle, which is it's going to end up being a shared object file. So what that means is it's like a DLL. It's like a dynamic link library. And the undefined dynamic lookup, what that means is that if I had undefined symbols when this shared object file is linking, don't complain. I'm telling the C compiler not to complain about those because those symbols will be linked at runtime when this object file is dynamically loaded. In case that what I just said is like new material to you, you don't actually have to really understand it in order to get this stuff to work. I like to explain the flags that I use. To be perfectly honest, I don't 100% understand what the dash bundle one does, but I know that these flags in combination create a shared object file, which is like a DLL on Windows. It's an object file that's meant to be linked at runtime with a binary. So now what I can do is I can say time equals require time. And what happened there is that it found my .so file. It loaded that .so file as a dynamically linked object file, and it specifically looked by name for Lua open underscore the name of that module, time. And then it ran that function. Now, if that function were to set up a table, which is the normal thing to do, then my time value would be a table. In this case, because I returned 0 from that function, it just gives me the true value, which is sort of a placeholder. It tells me I did load the module, even though I didn't get a table out of it. So the key takeaway from that demo is that Lua actually called my C function effectively by running this require function in Lua. Okay, so that's sort of a magic step right there. That's the first key step. And I'd like to show you the symbol table of my shared object file. This is a exported, publicly visible function called Lua open underscore time. I forget why there's an underscore prepended to it. So I can't tell you. I'm honestly not 100% sure, but it corresponds to the function of the same name without the underscore. And I can also show you what libraries it depends on, just this dynamically linked loader, essentially. And that list, those two lists of things, will get more interesting as the module grows. Right now, it's very minimal. But in case you're wondering, like, why am I showing you this stuff? Well, there's two cool tools. One is called NM, which shows you the symbol table, and I use it to see the symbols that are exported, which means that they are the functions that you can call that are defined within the SO file. And then the otool-l tool lets you know what libraries are depended upon by the .so file. Okay. And one other thing I'd like to explain before adding more value to that C module is the process of the require function. So the require function basically looks in a couple places. It looks in package.path for a .lua file. So I've looked at this. This is like a special string that by default is always defined as part of the standard library. And the way you understand the string, you look at a part that's not separated by a semicolon. So up to a semicolon is one path. You take the question mark and you replace it by whatever input string was given to require. And that gives you the full path of a potential file. It might not exist. If it does exist, Lua will use that file as the contents of your module when you call require. And in our case, none of these existed for our time module. So it went to the backup path, which is package.cpath, and now it's going to look for .so files. And the first place it's going to look is here. Again, it's going to replace that question mark with the string you give to require, so they would look for time.so in this path. To be perfectly honest, I don't 100% understand this load_all.so, but my limited understanding is that this is a catch-all shared object library that may contain a Lua open_time function. And so I think it's basically one place where you can, in one file, contain many modules. But I'm not an expert on that. But my understanding is that in practice it did not find the Lua open_time function there. So then it's going to go on to this last option, which is locally look for .so file. And that's the one that worked for us. And you can do things, you can manipulate these strings at runtime. So if I changed this path at runtime, then I could put the modules in any directory I like, as long as it can find it in the path. Another thing I can do is I can put my .so files in a universal location, like user local lib Lua 5.3. And then anytime Lua 5.3 is running, no matter where I am in the system, it will be able to find the module. All right, that's very useful to know if you are, for example, defining a C module and you want to allow third-party users to install your module on their systems in a very clean way. This is like a great place to put your module, and that way the user doesn't have to install it all over the place. If that's what they want to do. Some people like their dependencies to be local. And I will mention LuaJIT. So LuaJIT is an alternative implementation of Lua. It's the just-in-time compiler version of Lua. The most recent version that I know of runs Lua 5.1. So if you build a module for Lua 5.1, it will be very portable in that one .so file will work for LuaJIT, Lua 5.1, Lua 5.2, Lua 5.3, as long as you don't use anything that becomes deprecated in the later versions. Most features of Lua are stable. They don't become deprecated most of the time. You kind of have to check to know for sure. So if you're writing a module and you want it to be portable, you might want to write it using Lua 5.1 conventions, which are very similar to 5.3, but just small differences. And I will try to mention the main ones. But if you know for sure you're using the latest version, then you can use the 5.3 conventions. And I will tell you the differences that we're going to look at between 5.1 and 5.3. So the next step I want to do, did I leave this running? Oops, I left this running. Okay. The next thing I want to do is copy and paste some code that gives me sub-second resolution timestamps. So I previously wrote code that does this, and the code that I'm going to copy and paste is a little bit cross-platform. It will work on Mac or Linux, not Windows. So if you want it to work on Windows, I guess I can tell you the URL to use. If you want something that will work on Windows, I have a open source library called OSWrap, and I'll put the URL up here. Oops. Actually, I'll get a more specific URL to make it even easier for you. All right. Oh, it's a long URL. I'm gonna have to give you a shorter URL because otherwise it'll be hard to read. Okay. So that URL gives you the Windows version. If you go to now.c, now I'm going to go back to looking at Linux and Mac stuff. So I have this function called now. It returns a double. It's a pure C function. It has nothing to do with Lua. And because I'm on Mac, what it'll do is it will call, first it'll call mock time-based info, and that just gives us the a mapping between the timescale used by their internal kernel functions and seconds. So this mock absolute time function returns a very high resolution timestamp in a custom time unit, and then I convert it using the values I get out of this time-based info variable. I convert it into an absolute time in seconds. Okay, and that's a double that's returned by that function. All right, so that's a pure C function that has nothing to do with Lua, and now I'm going to add another C function that Lua will know how to call. Anytime you have a function in C that you want Lua to be able to call, it has the same signature, which means it has the same types as return values and as arguments. Hey Rondo Rules, what's up? Sorry, I'm not looking at my chat, so I might have missed it. Feel free to ask questions, viewers. I appreciate it if you do. So I'll tell you the meaning of these two parameters. The Lua state is a catch-all pointer that encompasses everything about the currently running Lua environment. So it has all the globals in it. It has what's called a Lua stack. And it's very similar to a C stack in that it has a bunch of arguments that are the input arguments to your function pushed on it. And when you exit, you actually will push on your return values on that stack. So the return value in C of your C function is going to be the number of values on the stack that are going to be returned in Lua. So as a reminder, in Lua, you can have as many return values as you want. You can have 0, you can have 5. You don't even have to declare ahead of time how many there are going to be. It could change depending on how the function is executed at runtime. So it's very flexible. And in order to capture that flexibility in C, because in C you don't have that flexibility, so in order to capture that flexibility, you just return the number of return values, and that actual return values are based on what's on the stack when the function returns. Okay, so I'm going to get the time, and in order to put that time on the stack, I'll call this Lua underscore push number function. And that's really the first Lua API C call that we're making. Just like it sounds, like it is going to take the number t, and it's going to put that on the top of the Lua stack. And then when I return 1, that tells Lua, okay, just take whatever's on the top of the stack, the 1 value, and that will be Lua visible as a Lua number. And like I said, in a future video, I'm going to cover a lot more of these C functions. This is just the bare minimum to get us started. Now, so far, I have defined a C function which Lua theoretically knows how to call, but the Lua user has no handle to that function. They need to have a value that they can call. They need to have like a name for this function. And I have to set that up. And that's the job of the Lua open function. So the way we do this, I'm going to look at the slide here for reference. Now I'm going to do this the Lua 5.3 way, and I'll mention the Lua 5.1 way. They're very similar. There is a struct called Lua L reg, which is, I think it stands for register or registration. And basically, you want to give it an array of these struct values. The first value, or the first field in the struct, is the Lua facing name. And I guess I'll just call it getTime. The second value in that struct is a C function pointer. Now what I could do, hey, what's up, Poish? I could define other Lua facing functions with other C pointers, other C function pointers if I wanted to. And I could define as many as I wanted to, theoretically. Now in our case, there's really only one function that I've defined so far. So I'm going to define that function here, and then I'm going to set null null, and that's a sentinel that tells Lua that's the end of the array. And then I'm going to call a specific function called Lua L newlib. Hey Hivani, welcome to the stream. Newlib sets up a Lua table on the Lua stack, and it sets the getTime key to have the value of a Lua callable function which wraps our C function. Okay, so this is a very typical C function for a Lua open initialization function for a module. So basically, anytime you have a Lua module, you will have a function that looks very, very similar to this, and you just kind of change the values of the function names here. Okay, I may have made a typo, so we might see a compile error. Let's find out. I'm going to compile this, the same line that I used before, and I did mess up. I forgot to include a header file. I have to include Lua auxiliary lib.h. And now is a good time to tell you the difference between this Lua underscore thing and Lua capital L underscore. The difference is that Lua underscore is in the core Lua library. Everything that's Lua underscore is defined in lua.h, essentially. And that is the meat of the C API. The auxiliary library are basically convenience wrapper functions that, their definitions are very small and they're built on top of the core API. And they have a capital L in their name to distinguish them. And they're defined in l-aux-lib.h. Now, in terms of what does that difference matter to you as a C developer? Almost zero difference. I think it would have been fine if the Lua designers had just made everything Lua underscore and they didn't even bother to tell you which ones are core functions and which ones are auxiliary. But, if you're wondering why there's a capital L there, that's why. Okay. So I added the extra include file, and great. It compiled the .so file. And now I want to test this out. So I'm going to require time. Great, so no errors there. And now I should be able to call time.getTime. And there's my timestamp. And you can see that it's higher resolution timestamp. Actually, why is it a different... value than that. That's a significantly different value. I don't know. I don't know why. I might be using the wrong system clock in my C code. Okay, honestly, I'm actually not sure why I got the weird value there, but what I'm trying to talk about for this video is how to call C, and that part at least is working. There may be something wonky going on with the conversion and the time. All right, so I'm not going to focus on that. Now I'll mention the hey programmer 122. What I've covered so far is the 5.3 way to do it. I will mention the 5.1 way to do it. It's actually extremely similar. The only difference is instead of using the newlib function, I would use a different function called Lua L register. So I'll write the code as if I'm doing Lua 5.3. Lua L register, and then the name of the module, and then the same functions value. And the reason there was a change is that it's considered best practice when you're writing a Lua module to not define any globals. Just because it's very, I sort of mentioned it earlier in the video, but it's nice to let the user control the globals completely and never touch the globals unless you are the end user writing the final script, not a library, but sort of a user-facing script. This function does define a global. That's why it's kind of deprecated. And it defines a global value for this time variable. But 99% of the time, that's what you'll want to do anyway, so it's not really that bad, in my opinion. But it was deprecated, and so people replaced it with Lua newlib. Doesn't define the global, but it just returns the value, and you have to use the return value of the require statement. Okay, so that's the difference between 5.1 and 5.3. And I will show you, now I'll show you how to put it in the universal path. I did mention this before, but I haven't actually done it. So you look at package.cpath, and that will tell you where it's going to look for these .so files. So what I can do, first I'm going to make sure that this directory exists. Yes, it exists. And now I'm going to copy my library into that directory. Don't look at my password. It's kind of a joke. And now I will, actually I'll remove the file just to kind of show that when I load it, it must be from somewhere else. And now I can say time equals require the time module. And it loaded. It would have given me an error if it didn't find it. And now I can write time.getTime. And it works. And if I call it again, I'm getting different values. To be honest, it does look like it is 1 second resolution. So I am slightly confused about why the timestamp doesn't match os.time. I don't know. I don't know why they don't match. What's up, Prox and DY Mus? Welcome to the stream. Okay, so I just demoed that we could put it in a universal location, and from anywhere in the system, we could load that module that we just built. Now, let's say that someone wrote a game, and you are writing Lua scripts for that game. There's a bunch of games that use this, that use Lua. World of Warcraft, Roblox, Dwarf Fortress has DF Hack as a kind of a Lua-based interface for messing with your Dwarf Fortress world through Lua. Other games have it. The people who wrote the game, including you, if you're the game developer, you can turn off the ability to load C modules if you want. And that's good to know because if you're writing the game, maybe you want to disable it. And if you are writing the Lua script, maybe you want to either use it or be aware that it could be turned off, just so maybe you want to check that first. The way you can turn it off is actually conceptually very simple. So the require function It's just a regular function. And if I want to turn it off, check this out. Require equals nil. Bam. That function is gone. Now if I want to require something, it's not going to work. Here we go. Doesn't work. There are a few functions that can load files, though. So there's more than just the require function. But the person who's writing the game, or who's sort of like controlling the Lua runtime, has the control to drop all of those functions. Am I using any of these modules? I am using the timestamp, sub-second timestamp resolution. Yes. Yeah, so I definitely use that. I've done some game jams where I use that, and the game I'm using uses it too. So, I guess that's actually everything I wanted to cover. So to wrap up, I plan to put this on GitHub. Maybe I'll put it on GitHub right now so that we can see, you guys can see where it is. If you're watching this on YouTube, then I will put a link in the description. And I'll give you a place to look for the example code, and I'll add a README which includes the values in these slides here. Let me see if there's any slides I didn't mention. No, that's the last thing I wanted to mention. Okay, cool. So let's see, Lua C module demo, I guess is what I'll call it. And I'll make a make-file. So let's see, I'll call this time dot. I guess the main output is time.so, and that will depend on time.c. And then dynamic lookup. I'm trying to remember this, make sure I get this right. Output time.so, input time.c. And let me make sure that actually works. Great. Now I'm going to get rid of the Lua stuff because you don't actually need the all the Lua source to do it. You just need a subset of it. And just to make it cleaner, I'm going to move the Lua files into their own directory so that it is easier to understand which files I wrote versus which files were given by the official Lua distribution. I have to change the make file a little bit to get that to work. Okay. Let's see. So let's make a Git directory, a Git repo. We'll add those files. I need to get rid of that tar.gz file. All right. And I will push that to GitHub. Awesome. So I guess I can finish by putting that URL up here in a slightly larger font. And again, on YouTube, the URL will be in the description of the video. And I'll add a README after I make this. So if you guys, watch this video and you want to go back and look at this stuff for reference without having to watch the video again, that will be easy for you to do. All right, thanks for watching the video, and next time I'll talk about the C API. I'll talk more about what it means to push and pop values to and from the Lua stack. How do you get like a table into C, a Lua table? How do you get C values converted into a Lua table? All kinds of crazy stuff like that. So if you like that, please follow me on whatever channel you're using, livecoding.tv or YouTube. Thanks for watching. I'll see you guys next time. Bye.